Dear learner, in this lecture, we'll go for a preliminary analysis of our structure, and before analysis, I'll go here analyze and go select load case to run. From here, you are able to control that which load will be run and which load will not be run. So here you can see it as per your requirement, but I want that every load we have defined will be run. And here a important thing, that show message after run. That means which message you want to show, error or warning, or only if error. Okay, so I will recommend you to show that option, or to select not that option, only error. Will also show warning also. If you have any warning, then you will see here. Then analysis monitor option. Okay, then actually no need to show that monitor option, because if you click on that option, it will just give you a pop-up, so nothing to do it. Then this option is not required at this time. When calculates diaphragm center of rigidity. So what is that actually? When you need the diaphragm center of rigidity, then you will be you will use that, but at this time no need to do it. That's why I'm not going for that option. And here automatic tabulate output after analysis is complete. So if you click here, this is no output, because no output is needed, because if you if you need actually any output in Excel format, Microsoft Excel output file, or Excel access output file, but I think not no output required initially. If you need, you can go for it. Then when everything is okay, you may click here run. Okay, now suppose you do not want to run for earthquake and wind load analysis, then simply just click here. You see, do not run. That means if we now go for analysis, our earthquake and wind load will not run. So I'll click here, I'll run for all, and simply you can click here run now, but I'll click here okay. Clicking here run analysis, I'll go. Otherwise, if you go here analysis, you can also go here for analysis, or also you may click for F5. Okay, now also they have another option, advanced SafeFair option. So we know that this software is based on SafeFair engine. So they have three options: standard, advanced, and multi-threaded solver. So this is for big size or better. Okay, this is actually a better solution, but I'll recommend you for this is best for structure stability check, and this is actually I will recommend you to use that option, because if we use that option, it is default, nothing to change here anything. And if you have any advanced requirement, or if you have any advanced guideline, then you will go for that option. I'll not use that option. Now when everything is ready, when we are ready, we're ready. And before that, I'll just go here analyze, check model. I'll select all, we'll check on model, then I'll click OK, and see if there any warning or any problem with our model. So please wait for some time. Okay, so model has been checked and no warning messages were generated, so nothing to worry about that. We didn't any mistake with our structure. When everything is okay, now I'll click here simply run analysis, and when you will click run analysis, your structure will start running your analysis, and it may take some time. It's totally depend on your PC speed. It's done. We have completed our analysis. Now you may see here, this is the deflected format of our structure, and it's showing displacement for our structure. And when everything is okay, now we have to go for different types of check. Okay, now first of all, we'll go for serviceability check. It's very important to check for serviceability. because it's mainly occur for our dead load, live load, then creeps. And if I just come here, see deflection limit analysis of a structure. If you see here, historically common deflection limits for a horizontal member have been 1/360 of the span of the floor subjected to full nominal live load. Okay, and L divided by 240 of the span of rope member. So we'll go for this for horizontal member. Okay, and this for span for floor subjected to, and we'll consider that, I mean this is the allowable limit of our deflection, vertical deflection of that structure, and this is the allowable limit of the deflection of our for live load also. And actually this is for roof member and this is for our floor member. And if you go here, 150 of the length for our cantilever member, and you may read it here. And also this you will get more details in code. So if I just go here in ASC 716 appendix CC2, okay, appendix CC2, this is the reference. Or if you just go here for vertical, ASCA 716. Okay, so this is the reference. You may get huge details study here, and also as per our country code, this is same as our ASC 705 code. So you may get that value here also. So we are getting value for that one, and we are getting value for floor member. This is the value for floor member for live load, and L by 240 for dead load plus live load. And for wind load we are getting that this is the deflection limit. Now we'll go for that check. Actually, to check it, I will go here, show deflected shape. Okay, show deflected. Otherwise, if you go ahead in display, show deflected shape or F6. Okay, then we'll click here. Now you'll go to combo, and for which combo we'll go for that dead load. That's why we have created that combo, or for all dead load. This is for all live load, this is for all roof live load. So I will go for that load. This combo is for total dead load, and I'll click apply. So when I have clicked applied, you may see here we are seeing the deflection. This is the maximum deflection. Here we are seeing this maximum 0.007 and another maximum is 0.028. That means this deflection is downward and this deflection is upward, and upward deflection is very low, and also it's negligible, but we can neglect it actually. But here for a minimum downward deflection, this is 0.528. This is the allowable deflection, and you may see here where this deflection is happening. This is the value of x direction, this is the value of y direction, and this is the height. So if you click here, I mean if you see here in x direction from that line, it's 11.5 feet, and this is for in y direction 9.6 feet. That means with respect to that column here also, here you will get the maximum deflection, and in at height 138. That means in the height of 138 we'll get that maximum deflection. So for that we'll go for that check. I will close it but sorry, I'll again click here, show deflected shape. For what we'll go for check, we'll go for live load. Not only live load, all live load, all nominal live load. So this will be included with floor live load and roof live load. For that we have to go here, and from here I'll take another combo. I'll take its name is all LL, that means all live load, and from here I'll select live load 1 plus live load roof 1, and I'll click OK, then click OK. So it's done. And now if I go here combo, for that to change that combo load, especially for combo, no need to reanalysis. So I'll just go here all live load, and I'll click here. Sorry, I'll go for deflection, and for all live load apply. See here, now we're seeing our deflected value, and this value is very less actually, 0.1904. 0.1904. It's very less actually. So what we'll do actually, now we'll check it, and where we are getting the maximum value, I will open our floor plan first. From our floor plan, you may see here, you may see this is our slab. This is the slab or size of slab. Now what we have seen that our total for floor it will be, what is the limit actually for floor? For floor, our limit is, maximum allowable limit is L divided by 3, or 1 divided by, I mean span length into 1 divided by 360. So what is our span length for that? Here I'll just click linear and take our span length from that point to that point also. For that take for ortho mode, (23 feet), and in that direction it's 16 feet and 6 inches. Now for which direction we'll go for check actually? See, if I take our calculator, suppose 16.5 divided by 360 into 12, that means 0.55 inch is the allowable limit for short direction. And now if we go for long direction, 23 into 12 divided by 360, then our allowable limit for long direction is 0.76 inch. That means if we go for short direction check, it's also comply with our long direction. So our short direction is 0.55, but if I go here, if we go to our software, we may see for that portion, or the maximum deflection here for overall, I mean any part of that structure, the maximum is 0.19, and it's 184 at height 184. So maybe this is the height for jet 126. I think for that slab, actually for that slab we are getting the maximum deflection for all live load. This is 0.19. Is it clear? So we can see that our allowable value for short duration is 0.55, but this limits is very less from that allowable limit. That means it's okay, our deflection is okay. In this way you have to check for the probable point where you are getting the deflection, the most deflection, you have to check for that point. And this is for on check. And for roof, actually, what is the allowable value for roof member? That is L by 240. So for that we'll go 16.5 or the short direction length, where we are getting maximum deflection, into 12. Into 12. We are making that inch, then we'll divide with 240. So for roof member, our allowable deflection for short direction is 0.82, but we're getting very less deflection, this is the maximum deflection here, 0.19. so I think no need to check for our serviceability check or for gravity actually at this time. Now this is for only live load, but for lower version of the code for ASC 705, if you follow that, you may get deflection for your dead load plus live load. So also you can apply. This is for dead load plus live load. Here is the limit. You may take a screenshot from here and also you can apply it. But I think and if you have any another requirement, you may go for that. I think it's okay. So in this way you are able to check your serviceability check. Okay, and if you have any other check in this way, you have to go for it. Okay, so in our next lecture we'll go for the most important check for earthquake and wind load. So thank you very much.